Hi everyone, I hope you're okay. This is a continuation video, guys. From the video where I talk about the second part of work, energy, and power, which is energy. On the previous video, we spoke about systems whereby mechanical energy was conserved. Are you together? And yes, mechanical energy will be conserved in a closed system, and a closed system should always have an absence of frictional force and applied force. Are you together? But not always the time, guys, you will come across a closed system. Sometimes you won't have a closed system, and if your system is not closed, it simply means that mechanical energy is no longer conserved. Are you together? Mechanical energy is no longer conserved. So whenever mechanical energy is not conserved, guys, there are tools we use to calculate our physical quantities. Are you together? We can simply use either your work energy principle. It simply says the net work done on an object is equal to the object's change in kinetic energy. Are you together? Whenever they say to you, state the work energy principle in words, you simply say the net work done on an object is equal to the object's change in kinetic energy. Are you together? So the net work done on an object is simply equal to the object's change in kinetic energy. Remember that, guys. On the first video when I introduced work energy and power, I taught you how to calculate work done on an object. Ne? That work is equals to F multiplied by delta X cos of theta. Are you together? So since I have work net over there, that simply means I'll say this will be F net delta X cos of theta is equal to the change in kinetic energy. That's half mv squared final minus half mv squared initial. That's how you deal with calculations whenever you're supposed to use work energy theorem, right? And then there is another tool we use, guys. We can use the work done by non-conservative forces. Work done by non-conservative forces is just equals to the change in kinetic energy plus the change in potential energy. Are you together? The only non-conservative forces we deal with in grade 12, it's only applied force and frictional force. So we'll simply have work done by friction plus work done by applied force. This is equals to half mv squared final. No, I won't have enough space. You'll simply say this is ek final minus ek initial plus potential energy final minus potential energy initial, right? Remember that, guys. Equations for kinetic energy and potential energy, ek is just equals to half mv squared, and then your potential energy is equals to mgh. I just don't have enough space to write over there, né? But we just substitute half mv squared final minus half mv squared initial plus mgh final minus mgh initial. That's how you deal with work done by non-conservative forces. Are you together? It's always safer, guys, to use this one because not always the time you will be given probably your angle theta over there. Are you together? So if you're not given your angle theta, it's very, very safe for you to use work done by non-conservative forces. But even if you are given the angle theta, as long as you have the height above the ground, please use work done by non-conservative forces unless you are being told not to use it. Because sometimes the examiner is very, very specific. They will tell you to use the work energy theorem. Are we together? Okay, let's just go in and do some practical examples. Okay, we are told that a girl slides down a rough surface inclined at 30 degrees with the horizontal from rest. She experiences a constant frictional force of 2 newtons with the surface. We must calculate the speed of the girl when she reaches the bottom of the incline. Remember that, guys, the girl will slide down, moving. She will start from rest. She will start from rest. If this is position P and that's position Q, the velocity of the girl at position P is 0 meters per second. I want to find out her velocity whenever she reaches position Q. Are you together? Don't worry, guys. I will use both. I will use both the work energy theorem as well as the work done by non-conservative forces. Are you together? Work energy theorem as well as the work done by non-conservative forces. Let's start with work done by non-conservative forces. I know that it simply says work done by non-conservative forces. Work done by non-conservative forces is the change in kinetic energy plus the change in potential energy, right? The only non-conservative force we have, guys, is friction. Are you together? Because no one is pushing the girl to slide down the incline. Are you together? So there's no applied force. The only non-conservative force we have a frictional force. So we'll simply say work done by friction is equals to half mv squared final minus half mv squared initial plus mgh final minus mgh initial. Remember that, guys, to calculate work done, you just need to find the magnitude of the force multiplied by the displacement traveled and then multiplied by the cos of theta. The magnitude of the force was just 2 newtons. 2 newtons, right? So it's F, which is 2 multiplied by the displacement and the cos of 180 degrees. Friction will forever oppose motion, right? So the angle between friction and the direction of motion is just 180 degrees. Okay, I'm looking for the speed of the girl when she reaches the bottom of the incline. Her mass is 35. Initially, guys, she slides from rest. Remember that, right? So initially her velocity is 0 meters per second. If the velocity, or rather the speed of the girl, is 0 meters per second, it simply means that her kinetic energy is also 0 meters per second. That's 0 meters per second. Okay, and then for the potential energy, you simply say potential energy final minus potential energy initial. The final destination of the girl is at the bottom there, at position Q, and her height above the ground will simply be 0 meters, because whenever she's at position Q, she's basically at the ground. Are you together? So this will be plus 0 minus her initial potential energy will simply be 35 multiplied by 9,8 multiplied by 3. So this will simply give us on the left hand side, I'll have 2 multiplied by 6 and the cos of 180. This will simply give me negative 12. Are you together? This will simply give me negative 12, and then I'll simply have 17.5 v squared minus, I'll just neglect these zeros, that's 35 times 9.8 multiplied by 3. Okay, multiplied by 3, that's basically 1029, 35 multiplied by 8 multiplied by 3. When I take the 1029 to the other side, it will be positive. So I'll simply have 1029 minus 12. That's basically 1017 is equal to 17.5 v squared. If I divide both sides by 17, I'll simply have v squared being equals to 1017, 7 divided by 17.5. Then the square root, I'll take the square root on both sides. 1017 divided by 17.5. This will simply give me an answer of 7.62 meters per second. Are we together? Okay, and then if we wanted to use work energy theorem, I think it's quite smart to draw our free body diagram first. Our free body diagram, you'll have weight. Let me use a different color. You would have weight, friction, as well as your normal force. Weight is gravity, Fk normal force. But sometimes you can use your free body diagram that has the components of your gravitational force. That means you'd simply have your normal force, your frictional force, as well as the component of the gravitational force. That means you have Fg perpendicular as well as Fg parallel. Are you together? You can use both of these free body diagram, guys, to calculate the speed. Are you together? For the first one, this one, I know that work net is equals to the change in kinetic energy. If I don't want to use the component of gravity, that means I don't want to use Fg parallel, I can simply say work net is equals to the change in kinetic energy. But remember that, guys, work net is the sum of all the works that I have over there. I know that I'll simply have work done by gravity plus work done by friction. This is equal to the change in kinetic energy. Always the time, guys, please note that work done by gravity will forever be equal to the negative change in potential energy. Always the time, work done by gravity will forever be equal to the change to the negative change rather in potential energy. So whenever I come across work done by gravity, I'll simply substitute negative change in potential energy plus my work done by friction is equal to change in EK, which simply means work done by friction is change in EK plus change in potential energy. And then this thing is similar to me because I did it over there. Work done by friction is equal to the change in kinetic energy and the change in potential energy. Are you together? If I didn't want to use my components of gravity, this is how I was going to calculate the speed. And obviously, if this statement is the same over here, that means I'll keep on repeating the same steps, and then my answer will simply be, why did I write a wrong answer? Ngiyathula nani. The answer is 7.62. Okay, and then I'll find the answer, which is equal to 7.62. Are you together? But now let's say I did not know that the work done by gravitational force is equal to the change in potential energy. Let's say I chose to use the component of my gravitational force. So that means I'll simply say that work net is equal to the change in kinetic energy, right? So it simply means I'll say that F net delta x cos of theta is equals to the change in kinetic energy. So what is F net? I only have two forces which are responsible for the movement of the girl. That is Fg parallel as well as the kinetic friction. But what is FG parallel? FG parallel is just mg, the mass of the girl, multiplied by 9.8, sine of the angle of inclination, that's 30, minus frictional force, which is 2 newtons. Are you together? And then my displacement, the girl will travel for a displacement of 6 meters, and then this will be cos of 0 degrees. F net is down the incline, and both F net and the girl are moving in the same direction, hence the angle is equal to 0. So I'll simply have half over here, and then I'll simply have 35 as the mass of the girl times v squared. Initially, the speed of the girl was 0 meters per second. That will make the initial kinetic energy to be equal to 0 as well. So let me punch my answer on the left hand side. I simply have 35 times 9.8 multiplied by the sine of 30 degrees minus 2. Then I close my brackets, open another one, multiplied by 6 times the cos of 0 degrees. This will give me 1017. 1 over 2 times 35 is just 17.5 v squared. Do you see that this step is the same as this one? Right, together. That you can therefore divide and then find the square root on both sides. Your answer will also be 7.62 meters per second. So you can choose, guys, whatever method you want to use. It's cool. Isospan. Okay, now let's do the last one. We are told that a 20 kg block is released from rest from the top of a ramp at point A at a construction site as shown in the diagram below. The ramp is inclined at an angle of 30. The ramp is inclined at an angle of 30 degrees to the horizontal, and its top is 5 meters above the ground. The kinetic frictional force between the 20 kg block and the surface is 30 newtons. Use energy principles to calculate the speed of the block at point B. The bottom of the ramp. They just want to find the speed of the block at point B. Ne? So this is position A, and that's position B, basically. So they want us to find the speed at the bottom of the ramp. They didn't tell us the displacement over here. Okay, since they didn't tell us the displacement, because it's very, very important, guys, for us to have a displacement when we deal with work, energy, and power, right? So I'll simply say that the displacement over here, let's pick any number. Let's say it's 10 meters. Yeah, it's 10 meters, ne? Okay. We want to find the speed of the box, or rather the speed of the block at position B. I can simply use the work done by non-conservative forces as well. Are you together? Work done by non-conservative forces or the work energy theorem. It doesn't matter. I'll still get the same answer. On your own, guys, please use work done by non-conservative forces. I know it's quite easy to use work done by non-conservative forces. I will use work energy theorem. So it simply says that the net work done on an object is equal to the object's change in kinetic energy. Are you together? Am I given frictional force? Oh, that's 30 newtons. Okay, work net is just equals to F net delta x cos of theta. This is equal to the change in kinetic energy. That's half mv squared final minus half mv squared initial. My F net is basically Fg parallel minus kinetic friction. How do I know that? Because whenever I draw my free body diagram, there's no force applied there. I simply have my Fg parallel my Fg perpendicular, as well as kinetic friction, as well as your normal force. Are you together? These two forces will just balance one another. So the only forces which are parallel to the direction of motion is Fg parallel and frictional force. And Fg parallel is in the direction of motion. Frictional force is just opposing my motion. So I simply have Fg parallel and kinetic friction multiplied by delta x cos of theta is equals to half mv squared minus half mv squared. Ne? That's final and initial. Gravitation, Fg parallel is just 20 multiplied by 9,8 sine of 30 degrees minus frictional force, which is 30 newtons multiplied by 10 and the cos of 0 degrees. The F net, guys, is just down the incline, so it's in the direction of motion. My F net, ne? Okay, so this is, oh my god, so this is equals to, excuse me about that, guys, this is basically equals to, this is equals to 1/2 multiplied by 20 multiplied by v squared, because I'm looking for the speed of the block at position B. Remember that, guys, the block was released from rest, which simply means that its initial velocity is 0. Anything multiplied by 0 will be 0. So the kinetic energy initial is just equals to 0. So this will just give me 20 multiplied by 9.8 multiplied by the sine of 30 degrees minus 30, close the bracket, multiplied by 10 cos of 0. That's just 680 is equals to 10 v squared. If you divide both sides by 10, then you'll find that v squared is equal to 68. Yes, and then the square root of 68. This will simply be 8.25 meters per second. That's how, guys, you're supposed to find your speed by just using work-net. Ne? But since I said you must use work done by non-conservative forces, we are supposed to say work done by NC is equal to the change in kinetic energy plus the change in potential energy. There's only one non-conservative force over there, which is just friction. So that's work done by friction is equals to half mv squared final minus half mv squared initial plus mgh final minus mgh initial. And I'm doing the work for you. I'm a bad teacher. I'm spoon feeding you. Okay, let's just continue. Work done by friction, magnitude of force multiplied by the displacement cos of 180. Friction is always opposing motion, né? So the angle is 180. That's 1/2 multiplied by 20. I'm looking for the final velocity. Minus the initial velocity was 0, and hence the change in the initial kinetic energy that will be 0, plus the height of the block whenever it is at position B will simply be 0 meters above the ground. So since the height is 0 meters, the potential energy will also be 0 joules. Minus mgh, that's 20 multiplied by 9,8 multiplied by the height. What's the height? The height is 5 meters multiplied by 5. And then what do we get? On the left hand side, I'll simply have a negative 20. That's 10 v squared minus 20 times 9,8 times 5. 20 times 9,8 times 5. What do we get? We simply get 980. Oh yeah, I used the wrong frictional force over there. I'm thinking, why would I get answers which are not the same? Remember that, guys, the frictional force was 30 newtons. Actually, I'm thinking of the previous question as case. Yeah, so over here I'll simply have negative 300 u. Remember that, guys, was negative 30. It was 30 newtons rather. So 30 times 10 is just negative 300. So now I'll just bring this thing to the other side. It will be positive. That's 980 minus 300. We'll simply get 680 is equals to 10 v squared. We had that statement over there. So you also calculate, and then you'll find the velocity to be equal to 8.25 meters per second. That's how, guys, we deal with energy principles if and only if mechanical energy is not conserved. Are we together? If and only if mechanical energy is not conserved. That's how you deal with work energy principles. Ne? If yeah, iphelele asingayidonsisi. Just stay tuned, guys, ne? And wait for more.